Why Jupiter truly terrifies astronauts. When people imagine space exploration, they often picture heroic astronauts planting flags on distant worlds, footprints pressed into alien soil under unfamiliar skies, the Moon, Mars, perhaps even worlds beyond our solar system one day. But there is one planet where that image will never become reality. That planet is Jupiter. In the grand architecture of our solar system, Jupiter is not just another planet. It is a force of nature, a colossal world so extreme that it challenges the very limits of physics, engineering, and human survival. To scientists, Jupiter is fascinating. To engineers, it is intimidating. And to astronauts, it is something far more unsettling. Because Jupiter is not merely difficult to explore, it is actively hostile to life. The giant that rules the solar system, Jupiter is the undisputed giant of our planetary family. It contains more mass than all the other planets combined, accounting for over 70% of the planetary material in the solar system. Its gravitational influence is so strong that it shapes the orbits of nearby objects and even affects the flow of comets and asteroids far beyond its immediate neighborhood. To truly grasp its size, imagine placing Earth next to Jupiter. Then add another Earth, and another, and keep going until 11 Earths stretch across Jupiter's diameter. And even then, Jupiter still feels massive, overwhelming, almost unreal. If Earth were reduced to the size of a grape, Jupiter would be the size of a basketball. This enormous mass gives Jupiter its terrifying power. And that power expresses itself in ways that no human environment ever could. A world without ground. The first reason astronauts fear Jupiter is also the simplest. You cannot land on it. Jupiter has no solid surface. There is no ground, no crust, no rocky layer where a spacecraft could touch down. Instead, Jupiter is a vast sphere of gas and liquid, mostly hydrogen and helium, transitioning gradually from thin atmosphere to dense fluid, and eventually to exotic states of matter deep inside. Descending into Jupiter is not like landing on a planet. It is like falling into an endless storm. A spacecraft attempting to land would simply sink. The clouds grow thicker. Winds grow faster. Pressure increases relentlessly. There is no moment where descent stops, no place to stand, no surface to anchor to. Downward motion only ends in annihilation. Storms that never die. Jupiter's atmosphere is the most violent planetary weather system ever observed. The planet rotates once every 10 hours, an incredibly fast spin for something so large. This rapid rotation, combined with its immense internal heat, drives hurricane-like jet streams that encircle the entire planet. Winds can exceed 400 miles per hour, dwarfing even the strongest hurricanes on Earth. And then there is the Great Red Spot. This massive storm has been raging for at least 350 years longer than the United States has existed. It is larger than Earth itself, a rotating wound in Jupiter's atmosphere that shows no sign of stopping. On Earth, storms dissipate when they hit land. On Jupiter, there is no land, only endless energy feeding the chaos. To enter Jupiter's atmosphere is to step into a storm that has never known calm. The radiation hellscape. Even before reaching the clouds, astronauts would face a far deadlier threat: radiation. Jupiter possesses the most powerful magnetic field of any planet in the solar system, about 20,000 times stronger than Earth's. This magnetic field traps enormous quantities of charged particles, creating radiation belts that dwarf Earth's Van Allen belts in both size and lethality. These radiation zones are so intense that an unprotected human would receive a fatal dose in seconds. NASA's Juno spacecraft survives only because its electronics are encased in a heavily shielded titanium vault. Even then, the mission was carefully designed to minimize time spent in high radiation regions. For humans, the required shielding would be so thick and heavy that it would likely make crewed missions physically impossible with current or near-future technology. Radiation is invisible, silent, unforgiving. And around Jupiter, it is everywhere. Pressure that destroys matter. Suppose against all odds, you survived the radiation and began descending. What awaits next is pressure beyond human comprehension. As you move deeper into Jupiter's atmosphere, pressure increases exponentially. Within minutes, it reaches levels that crush steel as if it were paper. This is not theoretical. We have seen it happen. In 1995, NASA deliberately sent the Galileo probe into Jupiter's atmosphere. The spacecraft transmitted data for just 57 minutes before being completely destroyed. Not by collision, not by explosion, by pressure alone. And Galileo barely scratched the surface. Deeper down, pressures rise to millions of times Earth's atmospheric pressure, forcing atoms into unnatural configurations. Hydrogen itself behaves in ways that defy everyday physics. No material known to humanity can survive such conditions for long. From deep freeze to stellar heat, temperature on Jupiter is just as unforgiving as pressure. At the upper cloud layers, temperatures plunge to extreme cold, far below anything found naturally on Earth. Ammonia freezes instantly. Spacecraft components would become brittle and fail. But as descent continues, the temperature rises rapidly, not due to sunlight, but because Jupiter radiates more heat than it receives. The planet is slowly contracting under its own gravity, generating enormous internal energy. Near Jupiter's core, temperatures may exceed 24,000 degrees Celsius, hotter than the surface of the Sunday. There is no gradual transition, no survivable range. You move from lethal cold to total incineration, with nothing in between. Liquid metal oceans. One of Jupiter's most bizarre features lies deep beneath its clouds. An ocean of liquid metallic hydrogen. Under immense pressure, hydrogen, normally a gas, becomes a conductive liquid metal. This exotic substance flows like water, but conducts electricity like copper. It is this ocean that generates Jupiter's colossal magnetic field. No human has ever seen it. No probe has reached it intact. Our understanding comes from physics models and indirect measurements. This alien environment exists nowhere else in the solar system on such a scale. A reminder that Jupiter is less a planet and more a laboratory of extreme physics. A planet that almost became a star. Jupiter's composition is strikingly similar to that of stars. Hydrogen, helium, trace heavier elements. The only thing missing is mass. If Jupiter were about 80 times heavier, its core pressure would ignite nuclear fusion, transforming it into a star. The result would be catastrophic for the solar system as we know it. Earth might never have formed, or if it had, it might not have survived. Because of this, Jupiter is often described as a failed star, frozen forever, at the edge of stellar ignition. This near miss gives scientists invaluable insight into how stars and planetary systems form. But it also underscores how close our solar system came to being a very different place. Gravity that offers no mercy. Jupiter's gravity is relentless. At the cloud tops, gravity is already more than 2.5 times stronger than Earth's. Any object falling toward Jupiter accelerates rapidly, reaching tremendous speeds before friction and pressure tear it apart. For a human body, the forces involved would be overwhelming. Movement would be nearly impossible. Structural integrity would fail long before reaching deeper layers. Nothing falls gently on Jupiter. Everything is pulled violently inward. A guardian and a threat. Ironically, Jupiter's terrifying power also makes it one of Earth's greatest protectors. Its immense gravity acts as a cosmic shield, deflecting or capturing comets and asteroids that might otherwise collide with the inner planets. Many scientists believe Jupiter has played a crucial role in allowing life to develop on Earth. Yet that same power makes Jupiter utterly inaccessible. It is a gatekeeper guarding the inner solar system, while standing as an insurmountable wall to explorers. where humans may go instead. Human exploration near Jupiter will likely focus not on the planet itself, but on its moons. Europa, with its thick ice crust and subsurface ocean, is one of the most promising places to search for extraterrestrial life. Io, the most volcanically active body in the solar system, offers insight into extreme geology. Ganymede and Callisto provide relatively stable environments for future observation posts. From these worlds, scientists may study Jupiter safely watching the Storm King from afar. The ultimate reminder: Jupiter is not evil.